Hi everyone, today I'm going to present you a demo on Kaldi, which is an open source toolkit for speech recognition and signal processing tasks. It's written in C++ and similar to HTK, which represents the hidden Markov model toolkit that handles HMMs, and it's used for speech recognition mainly. But based on my own research, Kaldi seems to be more popular than HTK. And now I'm going to give you some background information about Kaldi. It originally started to be developed in the 2009 in the Johns Hopkins University workshop. And another fun fact, it's named after the legendary Ethiopian goat herder Kaldi, who was said to have discovered the coffee plant. And back to the Kaldi code, like I said, it's open source, is well tested and easy to understand and modify. Anyone can contribute to it. And if you want to check out the Kaldi main page, you can find the information here. And there's some documentation here. The models tab will take you into this page, and you can see there are resources that are trained on English and Mandarin, and there are some other languages as well. And here's another main GitHub page where you can find the code and more documentation. So if you want to download Kaldi, it's fairly simple. You just need to, let's see, open up your terminal and copy this git clone command. I have already downloaded into my desktop, but for demo purpose, I will do that here again. You type in this line and hit enter. Oh, it says it already exists. And there's actually a lot of good resources on the GitHub on the Kaldi documentation page. You can see download and yeah, this is what you need. And to ensure that you have certain software packages downloaded and your environment is correct, you can find information here as well. Kaldi for Dummies tutorial. And you have here the environment, and the Kaldi directories has a main structure like this. And the most important directory is going to be EGS, where you can use go to create your own ASR system. For later demo, I'm going to use Kaldi toy example. It's a recording of a speaker speaking some animal names in Portuguese. So if you want to start with some free data sets, you can check out LibreSpeech, Tetlium, and AMI. And Kaldi also supports linear transforms, MMI, and deep neural networks. So one popular usage is to preprocess raw waveform into acoustic feature for end-to-end neural models. You can also use Kaldi to extract MFCC features and train for monophones and triphones. But for this demo, we're not doing that. So instead of using existing data set, you want to set up your own ASR system using your own audio data. Here's what you can do. You can go to the Kaldi EGS directory and create your project where you can store all the essential files into this directory. And back to terminal, we will git clone the Kaldi toy example using this command line. And after it's done, you can check all the files that are in this folder. And here you can see EGS. And inside of EGS, there's a data folder that contains local, test, and train. And in training directory, 5 files are required. Here you can see all the steps you need to do for data preparation. And those are the 5 files required for the train data. The wave.scp maps an address ID to the full path of a recording, and the text file maps a sequence of words to the address ID. And utterance to speak contains the mapping of each utterance to its corresponding speaker. And speaker to utterance is the file that contains the speaker to utterance mapping. You need to make sure your audio files are in .wave. But don't worry if your audio files are in other formats. You can simply type in a command line to convert everything into .wave. Speaker to gender maps the speaker ID with the gender. So for example, if the speaker's ID is the name Christine and it's a female, so you will map it with F. And for Josh speaker, you will map it with M. And in the terminal, when you type in list, you can see all the files in this folder. And you also need to sort the train and test directory in Kaldi. Here you can see the animal names in Portuguese files. And now moving on to the dictionary directory. The dictionary directory is under local and data. Here you will need lexicon.txt. It is a file that maps the words with their phonemes. We'll also need non-silence phones. So here are the files that you will need. And you can see what is in the lexicon file. What are the non-silence phones in the text file? And for silence phones, there's not that many. Optional silence, there's only one. And the corpus.txt we saw earlier is basically a text transcription of the audio. And I believe you don't have to do those manually. Kaldi will automatically do that for you. All the data preparation is done. You can run a scoring script to see, for example, what is the word error rate is. And for this example, we also need to download the SRILM language modeling toolkit, this command line here. But something did not work properly. And you usually would run this line run.sh to train and decode. And those are the running steps. It will return you a number in word error rate, but I ran into some issues, and this is the error message that I was getting. Assuming everything works properly, there will be an output.txt file. It would show you a highlight in red where the error exists, and you'll be able to go back to the folder and check on the specific audio recording. In summary, if you want to create your own audio data, you only need to create 5 files to add into the training directory. And you would also need a lexicon and non-silence phones, silence phones in the dictionary directory. And before running with the run.sh, and you'll get a result. That's it. Thank you.
Gato, sapo, gato, sapo.